So continue. Substitute this 10 in, that gives you 10 to the power 3 on 2. That's root 10 to the power 3, that gives you 10 root 10 minus 1. Therefore, well, that's the answer basically. So that's the end of the question, using integration by substitution to deal with this integral. And don't forget, we're looking for area. So it's unit square. So the next thing I'm going to talk about is integration by substitution. It's basically reverse chain rule. However, some of you might already want to ask me a question that how do you know which one to actually make the integration? Sorry, which one to make the substitution? In other words, look at this. How do you know if I let u equals to that one or let that one? Do we just let it to be the more complicated one? Most likely. However, in fact, that's not the case. So, to understand reverse chain rule, let's just take this same one as an example. So, let's just do indefinite integral to make it easier to illustrate. Now, we are basically having x times x squared plus 1 to the power of half. And which one to make to be the u to make the substitution is actually the one I call the target function. So in this case, how do I know which one is the target function? In fact, you don't know until you differentiate it. So I know this is the target function because the derivative of this function is 2x. Now, disregard the constant. Basically, I need a variable x. That's what I call the component. So this is the component. Just like exactly what I mentioned before, as the derivative of a linear function in the very, very easy example. In this case, the derivative of this function is still the component, which means you need this derivative to perform integration. Therefore, I'll write the derivative there. However, we can't just continue because this line is not equivalent to this line. All you need to do, multiply outside by half. And now, with this component, you can integrate x squared plus 1 as a whole function. In other words, this whole function has been to raise the power of half, and I can just apply the integrating power function rule into this whole function x squared plus 1. That is x squared plus 1 to the power of 3 on 2 over 3 on 2. If anyone have actually realized, this is the u. This is exactly what you did in this part. And that's why you get the half out there. In fact, in reverse chain rule, that half is to balance the equation. Balance your component without changing the question. And in this case, since I made the indefinite integral, so just plus c. And therefore, dividing by 3 on 2, that's multiplied by 2 on 3, which is a third. Now you can write a third, x squared plus 1 to the power of 3 on 2 plus c. Or you can write square root of x squared plus 1 to the power of 3 plus c. So what I'm trying to illustrate is that to make sure you know which one to make substitution, if you're using integration by substitution, you need to know which one is the target function. In fact, you know the target function by just reading off the derivative. If the derivative of that target function is somehow provided, not itself a multiple of them, then the target function is the one you put it inside the power. Okay, so I will have a look, a few more examples, see what we can have. Let's look at this. Integrating this one. Now, in power function is excuse me. In power function is really easy because whatever you're raising the power, that should be the target function. So in this case, if you are doing integration by substitution, you will let u equals to x cubed plus 3x squared plus 5. Okay, so I will do this as integration by substitution. And, oops, go away. Delete. Okay, so integration by substitution, therefore, now, just let du equals to blah, 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 and then you make up whatever at the front. However, now, I'm not doing this. I'll just go straight to reverse chain rule. So, if I do go straight to reverse chain rule, look at the target function. The target function here, in fact, is x cubed plus 3x squared y equals to x cubed plus 3x squared plus 5. And the derivative of that, which is the component I need for integration, should be 3x squared plus 6x. If you actually take out a constant as a common factor, that should be x squared plus 3. 2. And somehow the question must provide you this. Otherwise, it doesn't work. That's why there's x squared plus 2x at the front, somehow. But in fact, the component you need is this part. In other words, you actually need this to perform the integration as a whole thing, because this is the derivative of the function inside. This is the derivative of the function inside. So therefore, this part is the component. And can you do this? No, you can't, because you need to multiply by a third. The question doesn't provide the 3. Therefore, once this is done, you can integrate this as a whole thing, as a whole function. And give you to the power 4 over 12 plus c. And if you do integration by substitution, you'll definitely get the same answer. In fact, that is just the working out process of reverse chain rule, basically. So that's what I said. Reverse chain rule is doing integration by substitution without the substitution process. Okay, let's do a few more to get you familiar with this. Let's look at this one. So in this case, now the target function, kind of obvious, is the one in here. So now we have something at the front. Is this the one you want? Not really, because the derivative of your target function is negative 2x minus 1. That's the derivative of this function. And do we have negative 2x plus minus 1? We actually have more this case. We don't need to balance it. The reason, in fact, we need to is to multiply this by 7 outside. So how do I know whether I need to multiply by 7 or 1 on 7? In fact, there's only one rule of thumb. You don't change the question. Do a little simple expansion or multiply. Can you see if you can get the original question? If you can, you're on the right track. If you can't, you have done something wrong. Like the previous one in here, if I do a little multiplication, a third times 3, that would cancel. That will give you x squared plus 2x at the front, which is exactly the question provided. In this case, if I multiply the 7 inside these little brackets, that becomes negative 14x minus 7. That's exactly what's provided in the question. That's how you know you're on the right track. So now this is the component, and it's ready now for us to integrate. Therefore, so we're going to get rid of this. 7 stay outside as a constant, multiply by the whole thing, since that's the target function, to the power of 7 over 7 plus c. 7 cancel. Therefore, that is 5 minus x squared minus x to the power of 7 plus c. Now, if you're doing integration by substitution, again, you will get exactly the same answer. I would like you to try to do it now. Pause the video. Using integration by substitution, let u equals to 5 minus x squared minus x. And continue with that. Replace everything by u. If at the end you should get u to the power of 7 plus c, and then replace that u back by here. Again, I want you to do it now. All right, I'll do more. See what we can get. Down to some harder question. Well, these are all integration by substitution, as you can see. These are going to be your homework. Also, you can do integration by substitution without substitution, which is reverse straight away to reverse chain rule. So let's pick one. Okay, let's pick the two that I think that's hard to understand. Now, the one in here with the square root, it's a little difficult if you don't do substitution, because it's a bit hard to recognize what the component is, in fact. The reason is, if the component involves square root, it's a little bit hard, but I still can do it without substitution. So you can do the substitution yourself. Following the question, I'll go straight to reverse chain rule. So my target function in this case, it's y equals to root x minus 3. And how do I know that? Unfortunately, this is just by experience, because I in fact know the derivative of this function is somehow 1 on root x, which is, remember, this is x power of half minus 3, so that will give you half x negative half. And we should actually know this by now. The derivative of root x is 1 on 2 root x. So somehow it's right here. That's the component. Okay, that's the component. In other words, if I have root x minus 3 to the power of 4, I need the component is 2 root x at the bottom. So this serves as a component. 1 component. And in fact, can we do this? No, we need the 2 outside, because you can't change the question. Now everything is ready. Since I got the component, I can integrate whatever inside the brackets as the whole thing. To the power of 5 times 5 plus c. Therefore, that is just 2 on 5 root x minus 3 to the power of 5 plus c. Okay, so this is one of the harder examples to recognize. So therefore, now, by conclusion, if you're using reverse chain rule, technically saying it's all about recognition. You can recognize which one is the target function, which one is the derivative, which is the component, for your target function to be integrated as a whole thing. So I would write a few examples in here. For example, if I got 2x minus 1 minus x plus 5 minus 5 to the power of 7. So this is the target function, and this is the component. Because 2x minus 1, that's the derivative. Okay, or sometimes we have, as I said, square root function is really difficult. So therefore, for example, I have root x plus 5 to the power of 5, 1 dx, and I got a root x here. So this is the target function, and this part is the component. Kind of the component, you still need a 2 though at the bottom, but you can manipulate the constant yourself. So now here is what we're doing today for integration by substitution, with and without substitution. If you don't, that's called reverse chain rule. Well, technically saying. Now we will be dealing with a little bit more on reverse chain rule next lesson, which is tomorrow, and I'll post up the homework right now. You have a good day. Bye bye.